Hello, this is Mrs. Garbo, and this is the retrieval portion of Unit 2, Lesson 5, Be There or Be Square. In future lessons, you will work with quadratic equations. A quadratic equation can be expressed in the form ax squared plus bx plus c equals 0, using the properties of algebra and equality. It's important to note that a quadratic equation will not have an a value equal to 0. So you must have some a value that is not 0. Identify whether each equation represents a quadratic equation. Justify your answer. If we look at number 1, I see that x is to be multiplied with 6x subtract 11. I'm going to go ahead and distribute that and see what my result is. So after I distribute, I'm going to have 6x squared minus 11x equals 0. I definitely have an ax squared term, a being 6. I have a bx term with b equal to negative 11. And I know it doesn't appear we have a c, but if I were to add 0, I would have a c value of 0. So we can say that yes, this is quadratic because it can be written as a quadratic equation. If we take a look at number 2, we have everything on one side of the equation. So let's see if we can get everything on one side. I'm going to start by subtracting 6x squared. If I subtract it from one side, I have to subtract it from the other. But since that is the opposite of what is already on each side, what I end up with is x equal to negative 11. Even if I put the 11, add the 11 to the other side, I still don't have a squared term. So this is not quadratic. There is no squared term. And if we take a look at c, we have x squared minus 8x plus 4 equals 0. This equation is written exactly as our form was given to us in the directions. A would be 1, b is negative 8, and c is 4. So yes, this is quadratic. It is written as a quadratic, or I'm just going to say it is in standard form of a quadratic. And this next portion of the retrieval is review from Unit 1. Identify whether the table represents a linear or quadratic function, and write the recursive equation for each table. So I'm going to look at my first differences of my f of x values, and it appears I add 9, then I add 15, and then I'm adding 21, and then I'm adding 27. So my first difference is not constant, so I know it is not linear. If I check the second difference, it increases by 6, increases by 6, increases by 6. So that tells me that this is a quadratic function. And we're going to write the recursive formula. Remember, with the recursive formula, you always state what the first term is equal to. So f of 1 equals 3. And then we say that f of x is equal to the previous term, f of x minus 1. Our second difference is 6, so we have a plus 6x. But then we need to decide if we need to add or subtract anything to 6x. To do that, I'm going to take 2 times 6 is 12, but to get that second term we added 9. So to go from 12 to 9, I have to subtract 3, and that is my recursive equation. If we take a look at number 5, we increase by 3, we increase by 3, increase by 3, and increase by 3. Our first difference is constant, so this is a linear function. Our equation as a recursive equation is f of 1 equals 7. F of x equals the previous term, so f of x minus 1 plus 3. And that is the recursive equation for number 5. And this is the end of Lesson 5.